Hello class, welcome to Math Minutes video lesson number 40. We're going to start looking at polynomials. This is an introduction to polynomials, so turn to your notebooks to page 32. Introduction to polynomials. A polynomial is an expression with many terms. Terms are separated by operations. For example, 3x plus 4a times 5 has three terms separated by addition and multiplication. A polynomial with one term is a monomial. A polynomial with two terms is a binomial. A polynomial with three terms, you could probably guess this, is a trinomial. A polynomial with four plus terms is a polynomial with no special designation. So we only identify monomial, binomial, and trinomials, and then they're all just polynomials. A coefficient is another word for a number. The degree of a polynomial is the term that has the highest exponent. A coefficient is the number or constant in front of the variable. So a bunch of terms to help us understand our homework a little bit. Let's take a look at some examples of what these mean. Are these polynomials, trinomials, binomial, monomial, or a constant? Well, how many terms does this expression have? Each term is separated by an operation. So you can see that this is an expression, or a term, and this is a term, and this is a term. And you notice how I circled them, keeping the operation attached to the number, the constant or the term it's in front of. This has 1, 2, 3 terms in it, so this is a trinomial. This one, even though it's longer, we're not counting how many variables or exponents, but how many individual terms. Well, 23x squared y is all one term, and then the negative 12x squared y is another term. And this is two of them, so this is a binomial. Now, this is a term, but more specifically, it's a constant because it has no variable following it. It's constantly 17. No matter what we do with this is always 17. It is a constant. And let's take a look at this. Well, here's a term, another one, it's long, and another one. We have 1, 2, 3, 4, so it doesn't have a special name, it's simply a polynomial. So now we're looking at the degree and the coefficient. Can we identify what these things are? Well, the degree is the highest exponent. So in this one term, or monomial, the highest degree is a 4. So the degree is 4. Let's label this. I didn't label it. The degree column and the coefficient column. The degree is 4. The coefficient is that constant that's being multiplied, or that's in front of your variable. So the coefficient in 7x to the 4th is 7. What is the degree of this one? Well, it's our highest exponent, so the degree is 2. My coefficient is negative 2. Be sure and keep the negative attached to that 2 because it's part of the constant. Here's another monomial, and our degree is 6. Well, there's nothing in front of it. So is there a coefficient? There is. We don't write it down, but it's a number 1. There's always a 1 in front of it, even though we don't see it. Okay, let's take a look at this one. This one has I think I did something wrong. Let's go back to this one. The degree, there's a 2 here, but there's also a 1 there. And we kind of have to add them all up. In this one term, this has a degree of 3. I made a mistake. We'll be sure and go over that in class more because I realized it when I got to this one. We have a 2, and there's also a 1 there. This is one term. What is the degree of this term? Is we get to add them together. 2 plus 2 is 4 plus 1. This is a degree of 5, and the coefficient is 4. What's our degree here? Our degree is 1, and the coefficient is 6. So again, as we practice and use these a little bit more, so let's take a look at a few examples. We're going to simplify by combining like terms. If you recall from semester 1, like terms are terms that have identical variables. For example, 4xy squared and negative 2xy squared are like terms because the variable xy squared is the same in both terms. That means they can be added or subtracted. To multiply or divide does not require like terms, but to add or subtract, we do. That's a funny looking D. Okay, so let's take a look at what we can add or subtract. If I have 2xy and I want to add 3xy, can I do it? Yes, I first check. These are both xy, so that just stays there. But then I add my 2 plus 3, and that's going to equal 5xy. Well, what if I had x squared y plus 4x squared y minus 2xy? Okay, well, let's look at what I have. I have an x squared y and an x squared y. This one is not the same. I can only combine these two. And remember, there's like a secret little 1 in front of there. So this would become 1 plus 4 is 5. And then I just keep my little variable, which is the same, x squared y. But then I can't do anything with that, so I'm just going to minus 2xy. And this is as far as we can go. We cannot combine these anymore. Okay, let's try, how about 3a minus 2a plus 4a squared plus 3a squared. Well, which ones are the same? My a's are the same. So I have 3 minus 2 is 1a, so I'm just going to write a. And then I have a positive 4a squared plus a 3a squared. Well, a squared and a squared are the same, so I'm going to take my 4 plus 3. So that gives me 7. A positive 7a squared. I can't add these up any more than that because a is not the same as a squared. Well, negative 2x plus 3b plus 4x minus 5b. Well, even though they're not next to each other, I can do them out of order. This is why I want to keep my sign with my term. Here I have negative 2x adding a 4x. Negative 2 plus 4 is 2, and I keep my x and my x. Then I have a 3b, a positive 3b, minusing a 5b. So 3 minus 5 is negative 2, and then my term of b, I just stick with it, so that becomes 2x minus 2b. Oh, 42a squared by plus 39ab squared y equals what? The These aren't the same. I can't do it's nothing, it's the same. There you go. Very similar, but this is where we have to pay attention. What's being squared is the A, but what's being squared in this one is the B, so that one we can't do anything with it. And how about 14x minus 10x squared plus 4x squared minus y. Well, what's that going to equal? Well, I might have run out of a little bit of room. I'm going to write it underneath here. What can I combine? X is all by itself. So that's just 14x, but now I've got negative 10x squared plus 4x squared. So these are the same. Negative 10 plus 4 is negative 6x squared. And then I can't do anything with the y, and I know that it's going to be minus y because I have to keep my sign in front of it. And just a little technicality, this is the answer, but there's kind of rules like in scientific notation, two answers can be the same, but there's a right way and a wrong way to write it. We're going to write this from the highest degree. This becomes negative 6x squared plus 14x minus y. Everything's the same or same value, my negative 6x squared, but squared's going to come before the x, so that's my final answer there.